This is homework number 2, tutorial on Dalton's Law of Partial Pressures. Dalton's Law of Partial Pressures is very easy and you don't need to overthink it. The sum of the pressures will equal the total pressure. It really is. You just need to add the pressures together and make sure that they equal the total pressure. We'll do 1, 3, and 5, and we've made sure that all of the units are the same. That's usually the only problem that there is with doing these Dalton's Law problems, is that all the units have to be the same, and a lot of times we'll give you problems where you'll have to do conversions so that all the units are in atmospheres or all the units are in kilopascals. But for this lesson we haven't done that. They're all in the same unit, so really it's just addition, subtraction. So let's get started. If a balloon filled with air contains 79.03 kilopascals of nitrogen, 21.27 kilopascals of oxygen, and 10.1 kilopascals of argon, what's the total pressure? That's what I'm looking for. So total pressure is PT, and the way that I find PT is by adding all of the pressures together. Really is that simple. So I'll do 79.03 kPa plus the next one, 21.27 kilopascals of oxygen plus 10.1 kilopascals of argon. I'm going to add those three together, and that's going to equal my total pressure. So let's see what we got. Let's see over here. Will you be able to see? Yeah, it looks like it. 79. Oh, here, let me clear that. 79.03 plus the next one, 21.27 plus the next one, 10.1. Look, 110.4. Literally, that is all you have to do. It is simply addition. So my answer for the total pressure inside the balloon is 110.4 kilopascals. And we'll put our answer right over here. Voila, simple. All right, number 3. A sample of air from Mars contains 1.62 atmospheres of carbon dioxide, 0.0459 atmospheres of nitrogen, and 0.0272 atmospheres of argon. What's the total pressure of the air sample? Well, we're doing the same thing again. We're looking for total pressure. So that's PT up here at the top. 1.62 atmospheres of carbon dioxide plus 0.0459 atmospheres of nitrogen plus 0.0272 atmospheres of argon. So I'll write everything down. 1.62 atm of carbon dioxide plus 0.0459 atm of nitrogen plus 0.0272 atmospheres of argon. I'm going to add those together and I'm going to get my answer. 1.62 plus 0.0459 plus 0.0272 and 1.6931 atmospheres of pressure is my answer. I think I'm just going to go 1.69. Okay, 2 places after the decimal point is pretty safe. So my final answer, 1.69 atmospheres. All right, number 5. The propane gas used in camp stoves really contains 2 gases, propane and butane. It's just called a propane tank. If its total pressure is 770 millimeters of mercury and the mixture contains 545 millimeters of mercury of propane, what's the partial pressure of butane? Okay, so we're doing this a little different this time. We now have total pressure and we have 1 partial pressure. So I'm looking for the partial pressure of butane. So remember that PT is equal to pressure number 1 plus pressure number 2, because in this case we only have 2 pressures. We have butane and propane. So I'm going to fill in 770 millimeters of mercury for my total pressure. Set that equal to the first pressure that I have, 545 millimeters of mercury of propane. And then I'm looking for my P2. So looking at this problem, I think you guys could probably figure out what to do, but just in case you're unsure of yourself, which sometimes you are, 770 minus that number is going to give me that. Okay, so down here I'm going to do the work. I'll do 770 minus 545, and that's going to give me the partial pressure of butane. 770 minus 545, 225, 225 is my answer, 225 millimeters of mercury. And that's how much butane I have in there. So I hope lesson number 2 wasn't too hard. You guys get busy and do 2, 4, and 6.